All right, so yesterday's video went over a bunch of this stuff, but I'm just going to go over it since it was from a different source, so just want to make sure we're all on the same page here. So what we're doing is we're graphing these functions, okay? X-intercepts, I'm hoping at this point we understand what an x-intercept is, right? But if this is the x-axis, intercept would be going through, right? The x-axis could be going like this, whatever, okay? X-intercepts going through the x-axis. Y-intercept, if this is the y-axis, right, it's a point at which your graph is going to cross the y-axis. Okay, asymptotes. In the video yesterday, it seems like they just kind of started saying this word, and I don't really know how much you guys really understood it, but all it means is that it's an invisible line that your graph does not cross. All right, so just go back over the thing from yesterday, or the video from yesterday. This case, if the degree up top is greater than the degree on the bottom. Okay, what you'll have is no asymptote. All right, if the degree is like sort of flipped, so the higher degree, like this is x to the fourth, is on the bottom, your asymptote is going to be y equals 0. And if they equal each other, what you're going to do is you're going to take the coefficients. So it's like, I don't know, whatever. You're going to take the coefficients and just divide them by itself. So it would be y equals 3 over 7. That would be your horizontal asymptote. Okay, so for this example, this is the second example. The first example we went over, or I'm sorry, you guys went over yesterday in that video. So this second one, we are actually going to have to simplify. So the first step we should always do is factor this guy out. Okay, make sure it's all factored. So we get x plus 4, x plus 5, right? How did I get that? Well, I looked and said to myself, okay, this is a trinomial, which a is 1. So I said, what are my factors of c that add up to b? What are my factors of 20 that add up to 9, right? That's how I got the 4 and the 5. Sorry. Now what ends up happening is that the x plus 5 and x plus 5 can go away. And by going away, I mean just cancel out, right? Because you can reduce this fraction. And now this is the most simple form that we are going to graph. Okay, so in order to graph, let's figure out some things. X-intercept, right? If we look at the numerator, right, if we set it equal to 0, right, 1 can't really be set equal to 0, right? So your x-intercept, where this would cross the x-axis, it wouldn't, right? So there's none, right? No x-axis, or sorry, no x-intercept. And now what we're going to have to figure out is our vertical asymptote or horizontal asymptote. Vertical asymptote you find by setting the denominator equal to 0. And that would give us x equals -4, right? And that is a line. X equals -4 is a line. It is a vertical line. 1, 2, 3, 4. Right, which makes sense because it is a vertical asymptote, which means this is a vertical line. When you graph this, like they said yesterday on the video, when you graph this on the graphing calculator or anything like that, there won't be this dotted line usually. On most programs, they don't actually show it. It's just an invisible line, okay? Horizontal asymptote we find by looking at the degrees, okay? It's degree 0 over degree 1. Right, I'm finding the degree by the exponent on the variable, right? So there's none in the numerator, which means it's degree 0. Okay, so that means that your because the top degree is lower than the bottom degree, that means your horizontal asymptote would be 0, right? Y equals 0, which is this line right here. Okay, this is the horizontal asymptote. Okay. All right, now the last thing, the hole. How you find the hole is, oh, I'm sorry. The reason why we have a hole is because things are canceling out, right? When we factor this out and x plus 5 and x plus 5 cancel it out, that will lead us to have a hole in the graph. And it'll kind of make more sense, I think, once we actually graph it. How you find it is you take whatever canceled out, right? So this x plus 5, and let's solve that. I'm sorry, let's set it equal to 0 and solve. So that'll give me x equals -5, okay? Once I do that, I'm going to put that x value into my simplified form here. If I do that, I'm sorry, my simplified denominator, sorry. So I get -5 plus 4 equals -1. So my hole is happening at -5, comma, -1. Okay. Now, when we graph this, all right, there's a few things that we have, there's a few things we don't have. We don't have an x-intercept. We do have a vertical asymptote, which we already graphed in the green. So what does this graph actually look like? Well, what it looks like when we're actually graphing it is, okay, so I know that that hole is, it's not really part of the graph, but we do know that that's going to, oops, let's go back. Let's use this here. All right, there we go. Okay, so these are the two, you know, I wouldn't say, they're not two different graphs, they're the same graph, and it's the same function, but what's really happening here? Well, the reason why this is happening and the reason why it's so weird is because we are graphing a rational expression, right? That's what we're talking about in the last couple of weeks. Why does this look so weird? If you actually put this in your graphing calculator and look at the table, it's pretty interesting. And the thing I'm just going to talk about is this hole here. If I was to put this x value into the original problem, what would I get? I would get 0 over, let's see, 25 minus 45 plus 20. It gives me 20. So what's happening? So if I put an x value of -5 into the function, what y value am I getting? Well, the y value I should be getting is 0. So as x is -5, my y value should be the 0. But what do we know? We know that there's a horizontal asymptote at 0. So this can't actually happen, right? That's why they say there is a hole. The actual graph is not existing at this point. Let me try to erase it here. Okay, that's why we have a hole in the graph. Okay, it doesn't exist at 5, -1. Because if we put -5 into this function, we would get 0, right? Which can't happen. We have that as our asymptote, right? So that shouldn't be happening. All right, that's why there's a hole there. All right, last thing, or last example, I mean, I'm going to factor. So I get this is a trinomial with A being 1. So what are my factors of C that add up to B? My factors of -28 that add up to 3 are going to be 7 and 4. Since it's a +3 that is my B, this 4 has got to be negative. So I get x plus 7 and x minus 4. On the bottom, same thing. What are my factors of 35 that add up to 12? That would be 7 and 5. So I get x plus 7, x plus 5 on the bottom. Okay, that is the factored h. All right. If I cross these out, right, I get my final sort of simplified rational expression, right? And because things are canceling out, I already know that I should have a hole in my graph or gap. Okay, so first thing I'm going to do is find the x-intercept. Right? I I get that by setting the numerator equal to 0. All right. The vertical asymptote I get by setting the denominator equal to 0. Sorry, get rid of that. There we go. X equals -5. Horizontal asymptote I get from looking at the degrees of my variables there, right? They are the same, which means I put the coefficients, divide the coefficients to give me my horizontal asymptote. So 1 divided by 1, again, my coefficient here is 1, my coefficient here is 1. If I divide 1 by 1, I get my horizontal asymptote as, is 1, okay? So let's fill in some stuff. My x-intercept is 1, 2, 3, 4. My vertical asymptote is x equals 1, 2, 3, 4, 5. My horizontal asymptote is y equals 1. Okay. And, I forgot to calculate where my hole is. So the x minus 4 over x plus 5 is my simplified my simplified rational expression. So how I find my hole is I'm going to put x plus 7, I'm going to equal to 0, gives me x equals -7. I'm going to plug that into my expression, right? If I put -7 in there, I get -11 over -2, which gives me 11 over 2. So at -7, 1, 2, 3, 4, 5, 6, 7, 11 over 2 is going to be 5.5. 1, 2, 3, 4, 5, 6. Wait, hold on, sorry. 1, 2, 3, 7. 1, 2, 3, 4, 5.5. There we go. All right, so that's my hole in my graph. When I graph this thing, okay, and that's just me graphing it by hand. Again, I think if you, that's the whole. If you use your graphing calculator, it's going to help you out a whole lot. And again, if I put this -7 into this function right here, what I would get is 49 minus 21 minus 28 over 49 minus 84 plus 35. So up top, I would get 28 minus 28 is 0. I would get 49 minus 84 is 40, 30, 35. Yeah, 35, -35, sorry. And then plus 35 would give me 0. 0 divided by 0 is undefined. You can't divide 0 by 0. Can't divide anything by 0, but you definitely can't divide 0 by 0. So that's why you get this hole in the graph there, okay? But anyway, back to what I was saying. Using a graphing calculator for this stuff is really going to help you, personally, I think.